Hi, my name is Ori Steele, and I'm going to be giving a demo of encrypted data vaults. Encrypted data vaults are a technology that works with decentralized identifiers and verifiable credentials to provide a portability solution for users who are using decentralized identifiers to safely save their data across various different providers. All of the data is encrypted at rest and encrypted in transit, and only decrypted in the client. There's many uses for encrypted data vaults. Transmute, we're particularly interested in using encrypted data vaults to store trade secrets or information regarding transportation of raw materials in logistics networks. So first thing to note is you can check out this demo by going to did-edv.web.app. And from this website, you'll be able to explore the demo, and you can also link and read the specification for encrypted data vaults, which is being developed at W3C and Decentralized Identity Foundation. All right, so one other note is you can link from here to the Swagger documentation for encrypted data vaults. Encrypted data vaults are a REST API-based technology. Great, so in order to use them, we actually need to generate some keys first. So first thing you're going to be asked to do on the home page is create a key store of some kind. And when you go to this key store, you can see we don't have any keys. I could create one here, or I could go create a decentralized identity with Element and import that wallet here and use my Element DID. So we're going to do the slightly more complicated version for the purposes of this demo. So I'm going to go over here to Element. I'm going to come to the home screen, and it's going to ask me to create a wallet if I don't have one already. If you previously had an Element wallet, you will need to create another one because we've added support for some new cryptography. So here I'm going to create a wallet. I'm being asked to download it. That's to make sure that I have control of my keys. Now I'm going to import that wallet back into the app, and I'm going to unlock it. And at this point, you can see we have an ED25519 verification key, and it's hinting that we might have a decentralized identifier soon with this key ID. And in fact, we actually have to go create this Element DID in order to make this key resolvable. So let's go do that. So Element has already guessed what our decentralized identifier would be, and now we're just going to have to wait a little bit for Ethereum to confirm these transactions. So while we're doing that, I'm going to hop over to a Slack integration that we have, and we're going to click some previous transactions so that I can talk about what we're doing here. We're going to wait for our new transaction to be confirmed. So here you can see we have a Tenderly app integration in a Slack channel, and we listen for events on the Ethereum smart contract that point to that's used for Element. And in this case, just a few minutes ago, I created an Element DID, and this URL has been unwrapped from that Ethereum event. And when we click this URL, we can resolve this transaction. We can see that this is a side tree anchor event, that there was an anchor file associated with this Ethereum event. That anchor file pointed to a batch file, which in turn contained our initial DID document. So this is the exact same kind of transaction that we've just created. And you can see that in this document we've already prepared for working with encrypted data vaults by adding this ED25519 verification key, which we're going to be using for signing. So I'm going to hop back over here and see if this has come through. It seems like we're still waiting for our Ethereum network to confirm our transactions. This is on the Ropsten network. Seems like we have successfully anchored our decentralized identity, and we can see that we indeed have this key available now. So this means that we're now ready to work with encrypted data vaults because we have a decentralized identifier on a blockchain. We have some keys that are registered for it, and we have a wallet that contains the private keys associated with this identity that we can use for the demo. So let's hop back over here. Right, so now it's time to import the wallet file that we exported. So I'm going to import this wallet file. I'm going to unlock it. And I'm going to confirm that, in fact, we do have the key that we were just talking about. It's right here. So at this point, I can start to explore the encrypted data vaults because I have a decentralized identifier and I have a wallet with some keys that can be used to sign HTTP requests, in this case, associated with that decentralized identifier. So I'm going to come over here and I'm going to look at, I'm going to refresh for safety purposes because this is a brand new demo. And the first thing I want to point out is that we have added this extension for configuring which encrypted data vault you want to talk to. This is not standard, and we're looking forward to discussing whether or not this might be something the working group wants to adopt. We've just included it here as a way of discovering the encrypted data vault endpoint for a given domain. And so we look up the encrypted data vault endpoint from this domain, and that's how we learn about this URL here for creating documents. So right now it's saying that I'm logged in, or I have keys associated with this identifier, and I'm going to use this identifier and the keys in this browser to create a demo document. So I'm going to hit save here, and what's happening behind the scenes is that we're using those keys in the wallet file to sign some HTTP requests, which we're sending to our EDV server. And then those EDV server is using object capabilities to verify that this decentralized identifier has the capability to create those HTTP requests. We can see that that just succeeded. So now if we hop over here to look at documents, we can see we have this document. And if we click on it, we can see now we're looking at a URL on the encrypted data vault that has an identifier on the end of it, and it has our demo text. So the next thing we're going to do is we're going to make a big update to this document, and we're going to hit save. And the same thing is going to happen again. We're going to be signing a HTTP request with keys associated with our decentralized identity, and the server is going to be verifying object capabilities associated with that identity and this document. And we can see the update succeeded. And now when I go over here, we can see that this sequence number is now 1 instead of 0. So that tracks the fact that our update has succeeded. And finally, there's this configuration section over here, which sort of summarizes the concept of an encrypted data vault store. So we can tell that the reference here is actually a reference by name. It's the primary encrypted data vault store on this server for this controller. And we can see that it actually has an ID, which is a URI, which this is the ID of the encrypted data vault for this user. So this ID is actually this guy's primary encrypted data vault. So I could have more than one encrypted data vault on this server, and I could also have encrypted data vaults on many servers, and they would have different bases here. And then finally, there's this key agreement piece. This has to do with securing the documents that are going to be saved on this encrypted data store, and allowing for other users to figure out how to encrypt documents for me when they interact with the system. This is not currently used in this demo because I'm just creating documents for myself and downloading them for myself. So when I get my documents, the reason that I can show them in plain text here is that they're being downloaded, encrypted from the server, and decrypted on the client, and then I can update them. But I can't share these documents with anybody just yet. So stay tuned for subsequent blog posts and videos where we describe how to share documents with different DIDs according to the encrypted data vault spec. And that's it for now. If you have any questions, please open issues on the Element GitHub repo, or add comments to the blog post, or contact Transmute. We'll leave some links in the descriptions to the various different organizations that are contributing to encrypted data vaults, and how you can get involved. Thanks. Bye.